Here we have Venus, named for the Roman goddess of love. Venus is always the brightest planet as viewed from Earth, and as such holds a prominent place in the lore of many cultures. It's very easy to see in the sky. Then, when the telescope came along and we realized that Venus was actually a mysterious place rather than just a mysterious point of light, fantasies about alien life on Venus were common in the public consciousness from the 1930s to the 1950s. In some ways, this is our sister planet. It has nearly the same size and density and overall chemical composition as Earth, and it is the planet that can come closest to us as it travels through a nearly perfectly circular orbit. And that's where the likeness ends. Venus is completely covered in sulfuric acid clouds and a thick carbon dioxide atmosphere. It's so thick that only large meteors can make it to the surface and form a crater. It's so opaque that you can't see the surface from the outside. You can't even see the sun from the surface. It's dark down there. And standing on the surface would be like feeling the pressure of swimming 1 kilometer underwater on Earth. That surface pressure is high enough that you would be standing in supercritical carbon dioxide, which is a weird state where it behaves like both a gas and a liquid at the same time. Venus and Mercury could not be more different, but they do share something in common. Venus rotates slowly, just like Mercury. Venus has the slowest rotation of any planet in our solar system, and is slow enough to be a perfect sphere, like Mercury. And because of this slow rotation, its day is longer than its year, although not nearly as long as Mercury's. One of the most striking discoveries about Venus is that it has the same temperature all over the planet, no matter if it's the day side or night side, pole or equator. A scorching 470 degrees Celsius surface temperature, or nearly 900 degrees Fahrenheit. Venus is not the closest planet to our Sun, yet it is by far the hottest planet in our solar system. The Venusian atmosphere is extremely fast. It has extremely fast winds at high altitudes, and because of its high pressure atmosphere, it has very slow and yet very strong winds at the surface. Overall, the atmosphere rotates up to 60 times faster than the planet itself. What do you think happens over a long time with an atmosphere like that? The atmosphere effectively pushes on the planet's surface and thus tries to speed it up in the direction of those winds. And this is one reason why Venus rotates so slowly. The atmosphere and the sun both work together over time to slow it down. And then once the rotation came to a stop, the winds kept pushing. So now the planet spins backwards compared to most other solar system bodies. The sun's gravity is still a factor here, and it keeps Venus from spinning too fast in the other direction. So, this is all you can see from the outside. What's under all that? This is a radar map, made using data from NASA's Magellan Space Probe, which mapped about 98% of the surface in the early 1990s. This map shows both elevation and reflectivity. The colors show elevation, so low elevations start with purple and work their way up through the greens and yellows and finally up to the high elevation reds. Bright areas are highly reflective and dark areas are not. It's obviously not what you would see if the clouds were stripped away. Nevertheless, it can help us visualize different landforms and put names to them. The bright white areas at the tops of some of the mountain ranges is indicative of a sort of metallic snow-like substance, but it's not yet known exactly what it's made of. If you were to look around at the names of these features, you'll see a lot of Latin terms, so it helps to know what some of these refer to. Mons is a mountain. Montes is plural, so it refers to a mountain range. Planum is a high plateau, while planitia is a low-lying plain. Fluctus is an area covered by a volcanic outflow. A corona is a large, roughly circular or oval-shaped feature produced by magma repeatedly pushing up from the mantle and falling back down under the crust. Got a bunch of coronas here. Here's one, here's another, and another, all over the place. So when that magma actually does spill out onto the surface in one big and slow eruption, it can form a flat feature 100 kilometers across, but less than a kilometer high. This is known as a pancake dome. And this is a feature unique to Venus, and they are commonly found near the larger corona features. So for any given corona, you may find a few pancake domes nearby. Another unique feature to Venus is the tessera. It refers to the very heavily deformed terrain that appears to look polygonal, or as if it were a mosaic of tiles, like right here. This giant section right here is a tessera. And these are thought to be the oldest parts of the surface. These unusual landform kind of makes me wonder what kind of strange features are unique to other planets, especially those outside of our solar system that we won't get to see for a while. By the way, all 2,000 surface features on Venus are named for females, from first names in different cultures to women of history to goddesses of myth. There are 3 exceptions to that rule: Alpha Regio, Beta Regio, and Maxwell Montes. Maxwell Montes is right here, and this is Venus's highest mountain range, with Scotty Mons being its highest peak. These mountains are named for James Clerk Maxwell, whose work predicted the existence of radio portion of the electromagnetic spectrum. And radio waves are how we're able to peer through the opaque clouds of Venus and see a map like this. So, you got mountains, ridges, faults, and folds all over the place here. Does that mean Venus has shifting tectonic plates like we do on Earth? No, that does not appear to be the case. All of these landforms are actually explained by the activity deep in the mantle pushing around the crust. On Venus, the separation between the crust and the mantle is far too sticky for the crust to be able to move around on its own. Early on, Venus likely had an Earth-like environment. It's very similar in size, density, and chemical composition, and it probably had a lot of liquid water. However, at one point the planet heated up enough to evaporate all of that water, which then locked the planet into a runaway greenhouse effect. And now the atmosphere is thick and made of 95% CO2, carbon dioxide, and plenty of water vapor. It's hard to believe that Venus ever had any chance at life, due to the fact that it does not have plate tectonics, and it currently has over 1,600 major volcanoes. That's a lot of volcanic activity. 160 of those volcanoes are considered to be bigger than 100 kilometers across. has a lot of big planet-changing eruptions. On Earth, the big island of Hawaii is the only volcano complex of comparable size to one of the big Venusian volcanoes. And remember that we can only see the tip of the Hawaiian volcanoes. It extends all the way to the earth floor, to the ocean floor. But all of these volcanoes on Venus appear to be dead, with the possible exception of Venus's largest, Mount Mons. However, as far as we can tell, every few 100 million years, the mantle underneath the crust is reheated by the planet's core. And because there's no plate tectonics, there's not an easy way for Venus to blow off steam, so to speak. And therefore, temperatures continue to rise and rise until the crust weakens. And then suddenly the whole surface is basically covered in lava and completely recycled by volcanic processes until it cools down again. And then the cycle starts over. So, what have humans done with Venus so far? This planet has actually seen plenty of exploration already, with the majority done by the Soviet Union. There have been a whopping 40 mission attempts since 1961, from the Soviet Union, United States, Europe, and Japan. There were a lot of failures in those first 10 years of attempts, but mostly smooth sailing after that. There have been at least 10 successful flybys, at least 11 somewhat successful landings, 5 successful missions specifically going to the atmosphere itself, and 8 successful orbiters. One of those orbiters is operational today, Japan's Akatsuki probe, otherwise known as the Venus Climate Orbiter. From the name, you can probably guess what it's studying. One of my favorite missions was probably the Pioneer Venus Multiprobe of 1978, which was one big craft that dropped off 4 separate probes at different locations around the planet to compare various measurements. One of those probes was bigger than the rest, and it opened up a parachute at an altitude of 67 kilometers, so high. And then it sailed all the way down while watching the cloud layers go by. In spite of these successes, getting a lander to stay alive long enough to be useful in the harsh Venusian conditions remains a big challenge. That's all the time I have for Venus. Let's head for Mars.